demonstration of Platform AI. To start with, we need to log in. You can log in using either a Gmail account or your GitHub account. I'm going to pick Gmail. And it brings us to this screen, which has a few demo collections. We call them system collections up at the top. And if you scroll down, you should be able to create your own collection of images. And in order to do that, we need to give it a name. And then we need to pick a folder of images that's flat, essentially. So we don't want a nested hierarchy. We want all the images to be in the same folder. And then we can just drag those images in, and we'll see that those images are getting uploaded. Once the upload process is done, in your case that might take a little bit longer because you'll be uploading probably a few hundred images. In my case, I'm just uploading 10 images to illustrate how this works. Once the upload is done, you see the card appear here that you would click on essentially to start a project. I'm not going to do that because my collection only has 10 images. I'm going to scroll up and I'm going to pick one of the system collections here that has a much larger set of images. So I'll pick this one and I'll say I want to build a project related to the orientation of the car. I hit create. And then this screen will appear. This screen takes about a minute to load. What it's doing now is it's random sampling this image collection. I believe it has about 16,000 images. We want to pick about 500 of them. And we want to run those images through a pre-trained transfer learning network in order to get some projections that will help us do the labeling. So this will take about a minute. When this step is done, we see initially a grid of images appear. So it looks like it's starting to appear. And then once that grid fully loads, it'll start moving the images around on the screen to essentially give us views of the high dimensional space that we're in. So there are two toggles here. The first toggle is essentially going through the different layers of the transfer learning network that we've used. And the layers are essentially the meaning of the layers is essentially the level of abstraction of the concepts that the network is paying attention to. And then for each layer, you can change this to a projection, and the projections are essentially more like the principal components of a high-dimensional space. So here we can essentially toggle these around based on a combination of principal components. So in my case, I want to label the data based on the orientation of the car, and I can see already just in the last few seconds that there might be a good projection that I've stumbled upon that seems to be paying attention to the orientation. So if I want to select some images, I select this lasso icon from my toolbar. Once that's activated, I can essentially create a rectangle on my screen in order to grab the images in that part of the space. If I want to get a closer look at those images, I could have, of course, done some zooming and panning here as well. If I deselect the lasso icon, essentially turns it into a drag, and I can zoom and pan by essentially, using my trackpad. But I can also get a grid view by clicking on that icon and then just getting a closer look at the images here. And it looks like we've done quite well. We've actually grabbed mostly the right images. This one is the back of the car, so I don't want to include that in my class label, but everything else looks good. So I'll say this is the driver's side of the car, and I'll hit the plus icon, and this essentially creates a class for us called driver, and it puts 77 examples in that particular class. So next I want to see if I can find some images of the other side of the car. And it looks like this part of the space might be paying attention to that. So let's see what that looks like. A few examples here that I want to exclude. I should be able to kind of quickly sort through these. We're doing a little bit more work here than we did in our other example. A few more exclusions than we had to do earlier. But looks like everything else I grabbed is fine. So I'll say this is the passenger side of the car. And I can always come back and take another look at these labels if I click on these dot 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 buttons and I say edit label. I can bring up that grid view again if I want to take another look at it, verify, and make sure there wasn't anything in there that I inadvertently added that I didn't want in there. So far we have two classes. We have driver and passenger. Let's see, we might want to make another class, let's say the front of the car. In this case, I don't really see anything in this projection that makes the fronts obvious, but I can also just individually select images like this, one at a time. Obviously a little bit more tedious, but I can do that as well. So I can say here are some examples of fronts. And I can, now go to a projection that maybe makes it a little bit easier for me to see fronts. There's another front. And as you notice that, well, that's actually one that I already have in my library. But if I pick out some other fronts, you'll notice that it gives me a hotkey. So fronts are hotkey 2. So if I just hit 2, I've effectively added those images into that class label pretty quickly. So I'll go through, maybe try to find a few more. Maybe toggle a few more projections, see if there's one that stands out. There's another one in case I don't have that one in there. Here's another front. Here's another front. Looks like I'm having to do kind of a hunt and peck for fronts. Here's another one. And again, I can toggle projections. Looks like this one might have a couple I could grab. And this one is a front. So you get the idea. Now we've hunt and pecked basically 10 front images. So once you have a few labels like this, you can try to train a network. To do that, you would hit this icon here. You can get another random batch of images if you want by clicking on that random batch. As I said, this is 16,000 images. We can't view them all at the same time, so we're going to kind of get random batches to look at. Let's do a quick train. So this will take also approximately about a minute or two because it's essentially taking these images, training a network, having a holdout set from these images, and then measuring the accuracy of how well we did on that holdout set. So it looks like just with the handful of images that we've created, the accuracy is not that great. We're at only about 52%. I can kind of see my dial back here. And then as soon as it's done with the training and creating a new projection, I'll essentially get another screen full of car images. And it looks like a new batch of images are being downloaded. And this time, instead of using a transfer learning network, we actually have a network that is aware of the 3 classes that we're trying to label. And you can see there's some alpha effect being added to the images based on the certainty. If you don't want to see that alpha effect, you can turn it off using this button. And you can continue the labeling process essentially as I've done here. If you want to download a CSV of your labels and predictions, you can do that by hitting this download predictions button here. This is somewhat of a batch step, so you'll see the alert appear, and then a few seconds later, maybe about 30 seconds later or something like that, a file will essentially download to your desktop. There it is. So here's our downloaded file, and you can see in here we have the file name, we have the predicted class, as well as certainties and URL of the image essentially. A few other things that I'll show really quickly. You can do separation. You can maximize the distance between classes by selecting those classes. So let's say I wanted to separate the front of the car from the driver's side. I would select those 2 classes and hit this button here. This will maximize, this will essentially create a projection to maximize the distance between these. And so now it's giving us a projection that, as you can see, does have some space between the driver's side, which is down here, which now I should be able to label potentially a lot more images from pretty easily. As you can see, these are all driver's side, so I could maybe with 1 or 2 exclusions very quickly add a lot more labels. Now we're at 151 labels, and you can see the fronts of the cars are over here in this space. So that's a front, that's a front. Looks like we're still, this collection doesn't have as many fronts as we want, but you can see it's tried to maximize the distance between these. So by selecting those, I was able to at least pick out a few more classes of fronts of the car. You can also do find similar if you wanted to, depending on what projection, what layer you're on, you can do find similar. In this case, I may just try something for fun. I may just say, let's select a bunch of red images and then say, why don't you go and find similar images to that? So let me see if it'll bring back a list of images that are mostly red. What it means to find similar really has to do with what layer you happen to be on as well. So you may want to pay attention to that. But in this case, I'm pretty sure this particular layer is sensitive to color. So I want to see if that's my assumption is correct. I got a few more red images, but probably not as many as I thought. Let me switch over to a different layer. I could probably do better with color in a more basic layer. Maybe, yeah, it looks like this one is definitely paying attention to color quite a bit, so I'm going to try that step again and just pick this part of the space, which is almost all red colored cars. Maybe exclude some of these. And then try my find similar again. Okay, and I'm getting a new list of similar images. Let's see if this one did any better. Close my view so I can see it. And yeah, it looks like I do have quite a few red cars in this list. And then lastly, because we've been adding some labels, I'm going to try training a new network, see if my accuracy is improved. And it looks like our accuracy is improved pretty well. We're now at 73%. Based on the additional images that we added. And then it's also going to give us a new projection based on the latest network that we've trained. And we get a new list of random images, and this particular network should be pretty closely aligned with the task at hand, which is the 3-class classification that we've been trying to teach this network essentially.